In last class, we have covered some idea about the cloud computing and the types of cloud computing, public and private. And currently, we have also deals with some hybrid cloud, right? So hybrid cloud is nothing but the combination of public and private. So I have already covered in details about the public and private in the last class. At the same time, please only remember two concepts: elasticity concept and pay-per-use concept as far as the cloud computing, right? But today's agenda is totally concentrated. We will concentrate about the fog and edge computing, right? So see, I will explain in details. As far as the fog computing, the upper layer part is cloud layer, then the fog layer, and then the device layer, right? Device layer. This fog layer is nothing but the local area networks, right? Is totally, this fog layer is a part of local area networks. But after the evolution of Industry 4.0, that is we know industrial IoT, this device layer will remove. After the fog layer layer concept has been introduced, and after that the device will be deployed. So again, see, if you will deal with the only fog computing, then the first layer is the cloud, then the fog, then the device, before the industrial evolutions 4.0 IoT. But after the industrial IoT, after the evolution of 4.0, now the layer-wise approach is now changed. Approach is changed. Now first is the cloud layer, then the fog layer, then the edge layer, and then the device. Right? Device, since we are here, all students are related with, we are dealing with the IoT. So different type of IoT device, right? So IoT device is also related with your augmented reality, virtual reality, right? So augmented reality and virtual reality require very large bandwidth, very large bandwidth, and at the same time the delay requirement is very less. I'm just giving one example. If you are in SMEDU campus and wants to purchase one books only available at Singapore airport. So through AR and VR, you can able to see actual book, and after the wearing of this AR and VR device, you are actually feels these books. You can see front page, back end page, inside the materials through AR and VR. But to analyze this real time, the delay and bandwidth is very larger, and delay is very load is required. So as you know, when AR and VR will be comes into the picture, when backbone network is your 5G and R network, right? So we will not deal with here 5G and other things. So see the concept. So to reduce the delay, your device will near about to real-time processing. And to real-time processing, if this device will communicate with directly this cloud or edge. So let us assume that the delay from this to this, device to edge computing is T1, device to fog computing is T2, and device to cloud is T3. So you can able to analyze here T3 time is greater than T2 and T2 is greater than T1, right? So what we understood here? For real-time processing or industrial IoT device wants to process the data in the real time, they should be communicate with the edge computing device, right? Edge computing process, and then they will communicate with the fog. Edge will communicate with the fog, and then the cloud. So this is the process entire cloud to device. So what is the real-time examples? Let us take the one medical example. So see, if one patient is there and one sensor, heart sensor is deployed, right? They are analyzing the real-time data, and if the edge computing is not able to process the data itself, then they will go to the fog and then goes to the cloud. So the delay is so much, and so how the process will be complete? So first request, then response, right? So request and response time is known as, to process the data, the device will request and doctor will respond. So request response phenomena is appeared from the device to edge, and this time is known as round trip time. So round trip time means if the T1 time is for the request time and T1 dash time is the response time, so total time, round trip time is T1 plus T1 dash time. So if the device, this heart sensor will communicate directly with the cloud, you can think how much delay will appear. So before the doctor will send the response, maybe patient will not respond, right? And some serious issue will be appears. So to deal this real-time operations, fog and edge computing is developed, right? So fog computing is a basic concept developed by the Cisco, right? And at the same time, after this industrial IoT is the basic requirement for the industrial IoT. So now I will provide some actual informations as far as the agriculture concerns or medical concern. Medical concern I already told. This is the requirement. Okay. So first, why this the edge computing or fog computing is required? To reduce the delay. So basic concept involve this fog computing is delay optimized, right? Delay optimized. Second one is complexity. Reduce the complexity, right? Because if the device is able to provide all the information from the edge, then why they will compute by fog or cloud computing? So reduce the complexity. So third one is energy efficient. After the introduction of this edge computing, your IoT network is very, very energy efficient. So what is the benefit of this? So complexity is reduced, then this is really good for your medical deployment, medical operations, right? Second one, energy efficiency for the agriculture, right? Agriculture operations. Or one is very, very good example, if sometimes the fire is appeared in the forest, so the different sensors will be deployed by helicopters, and due to the energy efficient networks, due to this edge computing, the lifetime of these sensors will be increased. So instead of 6 months to 1 year, they can communicate to each other 6 years. And they will communicate with each other and nearby gateway. So gateway will communicate with the base stations, and base station is communicate with the your device. So what is the concept? So this is the really good example to monitor the forest firing conditions. If the temperature is very high, so since the energy efficient device is there, this device will communicate with the gateway, and gateway will communicate with your base stations, and base station with the device will connect with the your mobile or any device, right? Mobile device. So real time you can able to access the data real time, and delay is very low, right? If this edge computing is not there, fault computing is not there, they will all be processed through the cloud, and then this delay is very higher. So after long time, this device will observe there is a fire has been appeared in the forest. So to real time deployment, this edge computing is very playing a very vital role in these conditions. And so always remember that when the gateway is appeared, right, and local device is appeared, so all these processed by the your edge computing. As far as the fog computing, that is the local area networks, right? LAN networks are there, right? So what is the example? So I am giving the second example. In some zone are very sensitive as far as the earthquake conditions, like in Japan. So same way, if this is the sensitive zone, this is the sensitive zone, right? So sensitive zone, let us assume that this is the sensitive area where the plates are passing from these nodes, right? So nearby these plates, the sensor nodes will deploy, right? And these sensor nodes will be communicate with again the gateway, and gateway will communicate with your base stations, and base stations will be communicated to your device, and on your device or mobile device, within fraction of second you will receive the message there is a chance of the earthquake, right? So this is the real time example where the edge computing will play a very important role, because in real time fraction of second is required to deliver this packet. So how you can relate this one? So all are basically related with the delay, complexity, and energy efficiency. So edge is computing is provide a fraction of second. Fog computing is seconds and few seconds, right? And cloud computing is required sometimes the minutes also, right? So 60 seconds, 40 seconds, right? So larger amount of seconds is required. Or if you are not dealing with the real time operation, so maybe minutes to hour is also required, right? So depends on your priority customers, if which type of customers you are. So that depends on the cloud computing delay profile, right? So delay profile, complexity, energy efficiency is the very important factor for this edge, fog, and cloud computing. So I hope I have given two real-time examples. One is the fire condition in the forest, and second one is the earthquake information received in the fraction of second in Japan. And this is the currently all are using, but after the edge computing, this is the accuracy has been increased. Now I am explaining this edge and fog computing with some real-time example with the VANET networks, right? So regular ad hoc networks. I have already explained in your class VANET, mobile ad hoc networks, as well as I have also explained in details about the FANET, flying ad hoc networks, right? FANET is nothing but involved with the UAV device communicated with each other, at the same time manage mobile device, and all are ad hoc networks, and ad hoc networks is the reconfigurable networks, right? So you I think students, I think you already understood this concept. Now through VANET network I will explain this edge computing and fog computing. See here, so let us assume that this is the road where the different types of vehicles will be travel along the road from A to B, and some vehicles from this is the A direction, another one is the B directions. maybe the chance these both will be collide at certain point C, right? So accident has been appeared. So currently we are not able to find where the current positions is there and how the medical facility will provide to these persons, right? So this is the very good examples, because near by this road, one access point, that is also known as roadside unit, right? Roadside unit has installed. This RSU is communicated with the other RSU, and nearby this RSU is communicated with the base stations, right? So wirelessly they are connected, right? So, and this base station is optical fiber, and this will be connected with the cloud, right? So see here, if here is the one person, there are some parts has damaged due to the accident. So if the process will be appeared look like this, then the delay is very higher, right? Delay is very higher like this, right? So here to here. So how? So T3 plus T3 dash time is required. But the beautiful concept with the edge. If this edge will be installed here or installed here, right? Because every base stations have the base station is nothing but some storage device like your computer, like your CPU, right? So this information first goes to here and then goes to your cloud. So if this type of emergency data will process through this, then very difficult to provide the help to these type of people. So to provide the better solutions, some storage and computations device has been installed at the base stations or roadside unit only, so that they can directly send the information to the hospital, nearby hospital or nearby police chowki, right? So police chowki will also get the information, and nearby hospital also get the information in few seconds, so that ambulance service can be provided very sharply, right? So this is the I think base example to compute the medical facility emergency services through edge computing, right? If some delay can be tolerated, then we can prefer this fog computing, and fog computing is nothing but before the cloud, right? So cloud is here, so a small storage is before this cloud, right? So cloud dash is there, and yes, no doubt T3, so this is the T2 time. So if you want to process through fog layer, so time required is T2 plus T2 dash. But for the emergency service, this delay is still so much high. So in my view, for industrial IoT or revolutions in earthquake services, fire services, medical services, edge computing will play a very important role, and this is the very good example for better understanding about the edge computing as far as the fog computing. So hopefully students, in last class I was explained what about the cloud computing. Cloud computing nothing but cloud computing is just the combination of two things, that is the pay-per use and elasticity. Second one, the types of cloud computing. Types of cloud computing is two types, private and public, and third one is the hybrid, both, right? So when the security involved, then private cloud is preferred. When the open data is available, then public cloud is. If you are upload your data without there is no any security required, then public is okay. So some services the combined, some services private, some services public. You can also upload the data on the database. So that type of cloud is known as hybrid cloud. Now today's agenda was fog computing and edge computing. and why edge computing and fog computing is appeared due to the industrial revolutions, right? Industrial revolution 4.0, right? So what is the benefit of this? To optimize the network. Optimize the network in which way? Daily optimizations, complexity reductions, energy efficient networks. So in this class I was due to the time limit I was not covered the agriculture. Yes, as far as the agriculture also concerned, the fog and edge will play a very important role, right? So through this basics you can remember only 3 concepts about the edge and fog computing. One example is the fire has been appeared in the forest. Second one is the medical services, and third one is the accidental services appeared in the roadside nearby the roadside event. Hopefully you people understood the basic concept of the cloud computing, fog computing and edge computing. In the next class I will cover sensor on the cloud. Thank you.